Mr. Ahmed here again, working on Chapter 10. Goal for today is 10.2, finding arc measures. When we talk about arc measures, the first thing we need to do is define what a central angle is. A central angle is an angle of a circle whose vertex is right at the center. So in this case, B is the center of the circle, and this angle ABC, this whole thing, that is a central angle. Angle ABC. So 2 radii, vertex right at the center. In this case, the 2 radii are radius BC and radius B2A. So the central angle, vertex at the center. That is the key. Vertex at the center, central, center. All right? There will be some other angles inside of the circle, so we have to make sure we keep these definitions straight. The next step that we have going on here is the sum of the measures of all central angles in a circle. So, how many degrees are in a circle? 360. So in this case, we have angle 1, that's a central angle. Angle 2, also a central angle, and angle 3 is also a central angle. Since it makes the whole circle, all 3 of these have to add up to 360 degrees. 360 total degrees in the circle. Next one says find the value of x. So for this one, we're going to have to set up an equation. Let's see here. We have central angle, x, 85, 40, and this one's marked as 90. So all of these central angles have to add up to 360 degrees. So when I set up my equation, I would say x plus 40 plus 85 plus 90 equals 360. All of them have to add up to the whole circle. When I solve, combine like terms. X plus 215 is equal to 360. Subtract our 215 and x is equal to 145. We have found it. Next one. It says in circle B, angle LBM is 3x. So let's locate angle LBM. Trace it. Starts at L, goes to B. B is the vertex. Then to M. LBM. 3x. All right. Next one says LBQ. So L to B, that one's a little tougher to see. So I'm going to highlight that. LBQ. That's that whole angle. That one's 4x plus 61. So let's see here. What are we supposed to find? We're supposed to find PBQ. PBQ, that one's here. So PBQ and 3x, that goes back to the beginning of the year. They make an x. Those are vertical angles. Therefore, they have to be congruent. So I also know that this one is 3x. All right, so what are we going to do to find this? How are we going to figure out the missing piece? This one's a little bit trickier, that's for sure. So when I take a look at this, I see that this 3x and angle LBQ, they make a diameter. And how many degrees do we think's in a diameter? It's half of a circle, so it has to be 180. This whole angle makes a straight line 180. So LBQ, that one I highlighted, was 4x plus 61. And then plus our 3x over here has to equal 180. It makes a linear pair. So we have to notice those linear pairs. It's going back to previous knowledge. When I solve, 7x plus 61 equals 180. And subtract, 7x equals 119, and x is equal to 17. Now the question didn't say to find x. It said to find angle PBQ, so I have to put it back in. So the measure of angle PBQ was equal to 3 times x, so we have to take 3 times 17, which is 51. And I'm going to write it one more time, angle PBQ. So that was a little bit of a tougher one. That was 51 degrees. We had to multiply 3 times 17. Okay? Make sure you read the question so you know what you're finding. Moving onward. Step 2 is going to be defining an arc. Okay, so that's our goal here is arcs. An arc is a part of a circle that is defined by 2 endpoints. So it's a portion of the circumference. It's part of the circumference. Now when I think of an arc, I am going to indicate where the center of my circle is and then draw in 2 radii. All right, I just picked those random ones. Point A, point B. The arc is that portion of the circumference A to B. All right? And that arc, the measure of the arc is the same as the measure as its central angle. So let's just say, for instance, this central angle is 80 degrees. That means the arc is also 80 degrees. It's a portion of the circumference. The length of that arc would vary based on the actual size of the circle. So we aren't finding its length, we just know what portion that it is. It's 80 degrees of that circle. A minor arc is less than 180 degrees. Okay, so less than 180. In this case, the minor arc, A to B, that's 80 degrees, so it is minor. The way I name an arc is I draw a little curved shape above it and then name the 2 endpoints, A and B. Or I could also call it arc BA. So you have to put that little arc symbol above it to indicate that it's an arc. Otherwise, we'd think it was a segment. A major arc. Major. I'm still going to use our same points here. A, B, and obviously that's fairly small. I'm going to again say that's 80 degrees, okay? A major arc is greater than 180 and less than 360. So the major arc in this case does still go from A to B, however, it goes the other direction, all the way around. So that's a major arc, greater than 180, less than 360. Now to name a major arc, we have to have a third point so we know which direction we're going. The minor arcs are only named with 2 points, but the major arcs have to be named with 3. So I'll call this point C. So we'd go from A to B, but we pass through C. So I would name it using 3 points, A, C, B. The endpoints are still A and B, but it passes through C on the way. I could also go the other direction and call it arc BCA. Order's not important, just indicate which way we're going. If I just call it arc AB, I think we're going the short way. 3 letters means the long, 2 means the short. Major arc, greater than 180. Minor arc, less than 180. The one that's exactly 180 is called a semicircle. We just kind of talked about that in that last example before we even defined it. But a semicircle includes a diameter. So it cuts the circle in half. You have to look for these in problems, because we know that that semicircle is 180 degrees, okay? We still have to also indicate the circle, semicircle using 3 letters so we know which direction that we're going. So I'm going to go this way. I'm going from A to C, but I'm going to pass through B. So I would name this semicircle ABC or CBA. So in summary, when you name a semicircle, you have to use 3 points. A major arc, have to use 3 points. A minor arc, you use 2 points, okay? So, example time. Here we go. Name a major arc. So we have some options here. Major arc has to be bigger than 180. So let's go from B to C, but we'll pass through A. So B to C, but we're passing through A. So I would name that major arc, arc BAC. Next one says to name a minor arc, so a small one. Let's go A to C. And a semicircle has to cut it in half. So name it with 3 points. B to A, but we're passing through C. So arc B, C, A. That is a semicircle. It cut it in half. Next example includes the arc addition postulate. Okay. With the arc addition postulate, a couple key things here. The measure of an arc formed by 2 adjacent arcs is the sum of the 2 arcs. Okay. Our next step asks us to find each arc measure and state whether it's a major, a minor, or a semicircle. So, like we said, the measure of the arc is equal to its central angle. So for this problem, rather than me trying to answer each one of these, I'm going to try and fill in everything I can in the diagram before. That's my theory, is I'm going to do it ahead of time. All right? And then I'm going to answer the questions based off what I know. Now, if you want, you could find BC first and follow the steps and work your way that way. That's more than fine. But I'm just going to see what I know first. So the first thing I see, I know this 63 degrees, so arc AE is 63. All right? Vertical angles make an X. So that means this is also 63 degrees. These three angles have to add up to 180. So when I find CD, I have to take 180 minus 63 minus 90. And when I subtract those, I end up getting 27. So that means this one's 27. I wanted to show the work on how we got that there. And finally, this angle, BFA, and 63, those are a linear pair. That's a diameter, cuts it in half, so that has to be 180. So I'd take 180 minus 63 to find arc BA, or AB, how it's named. So if we take 180 minus 63, that gets us 117. So this arc is 117 degrees. I'm going to circle that in there too. So arc AB. For us to find AB, diameter 180 minus 63 is 117. Now we have everything all filled in. We just got to finish the problem. Arc BC, well, its central angle is 63, so it's equal to 63 degrees. Got it? AB, backtracking here, we found AB. We took 180 minus 63, that was 117. Good to go. Part B says that we're looking for CD. We took that by taking 180. The whole thing's 180 here. Found the diameter. Minus 63 and minus 90. All right. Next step says arc BDA. So let's locate B to D to A. So BDA includes all of the circle except 117. So you could do this two ways. You could take 63 plus 27 plus 90 plus 63. That's an option. However, I think it's easier to take 360 minus the missing part, 117. That's how I'm going to do it. 360 minus 117 is 243. Got it. Next one, D to E. Well, that was 90. Central angle is 90. And next one says D to B to E. So we got to locate D, B, E. So I'm going all the way around. Everything except D, E. So again, probably easier to take 360 minus 90, which is 270 degrees. Got that. And lastly, AEC. That's a diameter, so it has to equal 180 degrees. So, as you're working on these problems, a couple strategies. Look for diameters, all right? Those diameters cut the circle in half, so they're 180 degrees. I know this video got a little bit long, but lots of information. Like we said, this week is a little bit tougher, so really take your time and work on knowing these definitions. Have a good rest of the day.